Good morning, learners. Greetings for the day. I, Venkata Phani Babu, I have pursued my MTech from JNTUH in the field of AMS, Advanced Manufacturing Systems. Right now, I was pursuing my PhD in NIT AP, working as Associate Professor in the Department of Mechanical Engineering, MLR Institute of Technology. So, today's session I will be giving on Introduction to Lathe machine. The objectives of this session and the next session will be the history for the lathe and the purpose of lathe, why it has been invented, why it has been got full popularity in nowadays, and then we will go for the safety precautions on the central lathe, that is the precautions which we have, which any operator has to be taken while doing any machining operations on the lathe. Then we will be discussing on lathe diagram, we will be identifying main parts of the central lathe, then we will be discussing on working principle of lathe. Then we will be going for the specifications of lathe. Why specifications are important is, so for a particular operation we need some specifications for the lathe. So that specifications, how it has been divided or how it has been classified, that also we will be discussing. Then according to the specification, how many types of lathes are there, then what are the operating conditions for the lathe, then what are the operations we can do on lathe. Then what are the extra accessories which can be mounted on lathe, such that we can do a number of different operations also, which are traditional, which are more than the traditional operations which we can do. In the field of mechanical engineering, machine is defined as an assembly of mechanisms that are clustered together, that is, that are coming together in a such a way that it can perform certain operations by utilizing mechanical, pneumatic power, electrical, hydraulic powers. These are all used only to reduce the requirement of human effort as well as. So, in the field of mechanical engineering, machine is defined as an assembly of mechanisms that are combined together in such a way that it can be performing certain operations, that is by utilizing electrical, pneumatic, hydraulic, mechanical, what sort of power is available, we can use it. Only this machine is used to reduce the requirement of human effort and intervention in doing the task. It means that we are trying to less the human effort such that his or her intervention in machining will be reduced in a way that we can produce n number of parts in a less production time. So, machine tool is exactly not same with machine. Machine is different and machine tool is different. So, the term machine includes a variety of machinery, and machine tools must be power driven. Definitely, see, machine tools are to be power driven. Power may be of electrical, hydraulic, pneumatic, whatever it is. So, human operated machines are not machine tools, right? So, machine tools must be non-portable, and here portability is irrespective of the size. Maybe machine tool may be of 1 inch or 1 mm, or it may be of 1 meter or 10 meters. So, it is not at all depending upon size. So, machine tools are always firmly installed with the ground, that is, there will be some pedestal and a template will be given such that machine can be mounted on it. So, machine tools must have sufficient value. The value in the sense, value comes in the sense that it depends upon the capability and the performance of a machine and not on the basis of the cost. So, capability doesn't, value doesn't depend upon the cost here. Value depends upon the capability and performance. So, machine tool should be able to perform more than one type of machining or metal cutting operations. So, metal cutting operations will be mostly using in metals only, but this lathe or anything comes under machining only, right? So, it may be different materials can be done machining, on this. So, machine tools should be able to perform one or more multiple types of operations or multiple types of machining can be done on this type. So, operations may be including straight turning, taper turning, internal turning, threading, facing, drilling, coming to boring, reaming, tapping, milling, shaping, planing, slotting, broaching, hobbing, grinding, etc. or different types of operations, right, which a machine tool can be done. Mind my word, we are not talking about the lathe operations. These are the operations which are involved in machining of a metal, right. So, machine tool should utilize a cutting tool to shear of excess materials from workpiece in the form of chips. So, shear in the sense, here we are removing the unwanted material from the workpiece material. Shearing means we will be tearing off, right. So what are the functions of a machine tool? A machine tool should transmit power from the primary mover such as electric motor, that is the power source, to the required location and when necessary for cutting or machining action. So for any operation, machining operations, it should transmit power from the prime mover to the required location. That is maybe in the interaction of a tool to the workpiece. So it provides necessary motions to accomplish cutting action. Cutting action in the sense it is shearing action, right? So these motions include but not limited. So mind this word, this is but not limited to cutting velocity, feed motion and depth of cut. But these three, that is cutting velocity, feed motion and depth of cut, are main parameters for any machining. So it also manipulates power and motion, including transformation of one type of motion to another, such as rotation to translation or oscillation, reduction or increasing of speed, changing the direction of rotation, that is in clockwise or anti-clockwise, whichever is favorable for that particular machining operation. So it should support and hold workpiece and other necessary devices, that is tool holding devices such as cutting tool. Also it should be providing an accessory, or it should be providing a provision to have coolant pipelines in order to reduce the friction or in order to reduce the heat produced when a metal countered with another metal. It also should transmit cutting force and the vibration to the ground. So when metal to metal interaction is being happen, there may be vibrations coming up which is not desired for the shape of the material or for the surface finish of the material. So that vibrations which are encountered should be absorbed to the ground through some pedestals or whatever shock absorbers or something like that. Usually it provides a better cutting fluid discharge facility. This cutting fluid we will be calling it as a coolant pipelines only, right? So finally it produces an ergonomic platform for human workers to carry out machining. So here in the first slides we are saying that to reduce the human effort, we are going for machining with the machines, right? So but there should be some operator, that is human operator, to carry out machining. Nowadays we are having robotic operated machines also. So but still a human is needed to intervene the program which has to be given to a robot. So why lathe is not a machine? Generally everybody will be saying lathe is a machine. Lathe, even in our title we are saying that introduction to a lathe machine, right? So actually lathe is not a machine. By the definition of machine, any kind of lathe can be called as a machine, right? So lathe, because we are going for n number of, that is more than one type or more than one type of machining operations can be done. So in the metalworking or machining field, it is commonly termed as machine tool. So actually lathe is a machine tool only, not a machine. Since the lathe qualifies all 5 conditions as mentioned above, it is one of the machine tool. The term machine tool has a specific significance in metalworking field as it indicates the worth of a particular machine. So the worth of particular machine, worth don't go in a different manner. So worth means it's not the value, it is the performance of different operations. So traditionally it is also believed that the operation on lathe is mandatory for making any mechanical product, even for making any other machine tool. So this machine tool, that is lathe a machine tool, being a machine tool, can also produce different machine tools for different operations also. So due to its extreme capability, people associated with metalworking field love to designate lathe as a machine tool only, not as a machine, right? So therefore lathe is not a machine, it is a machine tool. Please remember that lathe is always a machine tool which can produce different types of machine tools for different types of operations. Now coming to the history of lathe. Lathe is a forerunner of all machine tools. Before BC's only lathe has been invented, but the first application for a lathe was the potter's wheel. So Henry Maudslay, which you are seeing on right side top, he was the first inventor for the lathe which has been used for pottery wheel. So in this pottery wheel, a rotated clay is enabled such that it can be formed into a cylindrical shape, and this wheel is very versatile, used for turning, tapering and form turning. and also for screw cutting, facing, drilling, boring, spinning, grinding and polishing operations. This potter wheel, which has been invented by Henry Maudslay, has been used for turning the clay, tappering a clay, form turning can be done with a screw cutting, facing, drilling, boring, spinning, grinding and polishing operations could be applied in this potter's wheel. So this history was before BCs only. So why does lathe came into very significance for the industries? So once before World War there was no industrial revolution, but after the World War there was an industrial revolution which has been developed and which has been demanded for producing n number of parts. So for production, for increasing our production, we are supposed to use lathe such that the same product can be multiply produced fast, more precision according to its design, according to its tolerances and what dimensions. We can go, we can achieve almost 95 to 99% precision in lathe. Changes in manufacturing process, since because demand has been increased after the World Wars, then the traditional manufacturing processes are become very slow for producing products. So the change in manufacturing process, the way it has been, the product has been manufactured, we are changing the process, and this led to development of high speed machines to be enrolled to the market, such that this high speed machines will be used to change the manufacturing process for increasing the production along with high precision to be achieved. So there are some special purpose lathes which are designed only for tool room designs, that is those tool room lathes will be used only to produce some specific standard gauges or standard devices, such that can be compared to the machine tools which are being produced with our lathe machine tool. Right. So the main purpose of a central lathe. So central lathe is one of the type of central lathe, and we will be discussing in the due slides as that why it has been called as central lathe. So lathe is a machine which removes a metal from a piece of work to be required shape and size. That is, removes here in the sense it is shearing the metal from a piece of work, that is workpiece. It will be removing the unwanted pieces from the workpiece to the required shape and size. Lathe is one of the most important machine tools in metalworking industry. A lathe operates on the principle of rotating workpiece and a fixed cutting tool. So operation of lathe depends upon the principle of a rotating workpiece which is fed against the cutting tool. It is fixed. Cutting tool is always fixed here, and workpiece is in rotary motion. So the cutting tool is fed into workpiece which rotates about its own axis, causing the workpiece to be formed in the desired shape. So mostly the workpieces forming in the desired shape will be in cylindrical. Mostly 90%, 99% will be in the cylindrical shape. So because of all these purposes on a lathe, it is also known as the mother or father of entire tool family. Lathe is called as mother or father to the entire tool family. So 90% of 92, we can say 95% of any machining operations can be done on lathe by its original building or by some additional accessories also. So lathe machine is used to produce cylindrical work. As I said in the previous slide, desired shape 90% it will be of cylindrical work only, cylindrical shapes only. The workpiece is rotated while cutting tool movement is controlled by the machine or an operator. So the tool movement, the cutting tool, as we said that cutting tool will be always in fixed motion. This movement will be controlled by the machine or the operator. Machine in the sense it is in programming way, right? So lathes may be operated directly by the people, that is called as manual lathes, or computer controlled lathes, that is called as CNC machines, that have been programmed to carry out a particular task. But here, which are being directly operated by people are called as manual lathe. Even for the CNC machines, programming should be done by the people only, right? Once the program is fixed and once the program is finalized, it will be fed into computer controlled lathes such that the operation will be automized, right? In between, once the operation is started, in between there is no human intervention at all. But in manual lathes, human should be there, that is operator should be operating, because he will be controlling the cutting tool movement. The function of lathe is to remove excess material in the form of chips by rotating the workpiece against a stationary cutting tool. So the material removal, that is the shearing of material from the original workpiece will be in the form of chips. So the removal will be in the form of chips. Chips will be very small. It's not like our potato chips, metal chips only here. Now coming to the precautions, safety precautions which any operator who operates lathe has to follow. He has to wear approved safety glasses, since we are saying that material removal will be in the form of chips. So, and also the principle says that lathe will be having a rotating workpiece with a fixed cutting tool. So nobody can expect which way the chip being sheared from the original workpiece will flow or will be fly in what direction. So always to safeguard our eyes, we are supposed to wear approved safety glasses, and we should roll up our sleeves and remove tie and tuck in loose clothing only. So always this sentence says that we are not supposed to have any loose parts hanging out of the human body, and never operate machine if safety guards are removed. So if at all there are any lathe company, any lathe manufacturing company will be giving some safeguards. So if someone when in absence of you has removed safety guards, you are not supposed to operate that machine. So always remember that while starting a machine for a machining operation, you are supposed to check for the safety guards are intact or not. So stop lathe before measuring work or cleaning or oiling or adjusting a machine. So you are supposed to stop the machine whenever you want to measure the work. So while it is rotating, you are not supposed to measure it, how much length it has been done or how much depth it has been taken out, how much diameter was there in internal or outer, OD or ND, ID internal and outside diameters. And while cleaning the bed also, you are supposed to stop the machine, then you have to do. And for oiling the bedways or any greasy holes are being given, you are supposed to stop the machine, then go for the oil or greasing. Even for adjusting the machine, you are supposed to stop the lathe, then you are supposed to adjust it. Even including when we are coming for alignment also, if alignment has been disturbed in between some operations, you are supposed to stop the machine, then go for alignment. Always remove chuck key after use, since a chuck key is very important part which holds the workpiece in the, what we can say, workpiece in the chuck, that is work holding device. So for tightening the work holding device chuck, we are using chuck key. Chuck key is an external protected part which makes a chuck to rotate equally and hold goods the workpiece. So this chuck key, that is the projection part, has to be removed before starting any lathe. And we are supposed to remove chips with brush. Once the machining operation has been done or machining operation has been completed, if there is a flow of coolant is there, then automatically chips will be moved out. But still, when we are trying to change the workpiece, another workpiece, or when we are trying to mount another workpiece on the lathe, then we are supposed to use brush to remove all the chips. So as chips will be very sharp, we will be removing it from the brush. From this side, we will be stopping this session, and we will be continuing in the next section by going with 2D and 3D diagrams of lathe and different types of lathes, as well as different specifications of lathe and different operations of the lathe. Thank you for this session.